Alright, so today we're going to be doing transformation of quadratic graphs. And quadratic graphs are ones like these that have a squared. For these first four problems, we're going to put it in vertex form. And vertex form's up here. So we want to put our A on the outside. We want to have a perfect square binomial right here. And then K on the outside. So we're going to start this one the same way we would completing the square. The only difference is this is not going to be equal to 0. So I want you to go ahead, put A on the outside. Our A is 1, so we don't really have to put it. X squared plus 4x on the inside. I want you to put a plus blank. And the 6 with completing the square usually usually we'd have to move the 6 on the other side of the equal sign, so we'd have to subtract it. But since we're leaving it on the same side, we can just put plus 6. We don't have to change the sign, again, because we're not moving it to the other side of the equal sign. Okay? The next part, I'm going to put a blank on this side also. For completing the square, we would find b over 2 squared and add it to both sides. So in this case, we still do b over 2 squared, so our b is 4. So 4 over 2 is 2. Squared would be 4. So we're going to add 4 in here. And on this side, we're actually going to subtract 4. Why subtract it instead of add it? Well, we don't want to alter this equation at all. We're not trying to change it. We're just trying to put it in a different format. So the reason we have to subtract 4 on this side is because if we were to simplify this problem and combine our like terms would be 4, 6, and negative 4. So if we combine these right here, the 4's would cancel out, correct? You'd be left with x squared plus 4x plus 6, which is our original equation. So if we had an equal sign set equal to 0, we would add 4 to both sides, like completing the square. But since there's no equal sign, and we're not changing the sides, we're going to have to subtract it from this so we don't alter our original equation. And why do we do it like this? The reason why is because we need to change this, which is a perfect square trinomial, into a binomial squared. So it will look just like vertex form. Okay, so nothing's changed about how we fill this part in from completing the square. It's always going to be x right here. Whatever this number is going to be our b, our middle term, divided by 2. So 4 divided by 2 is going to be a positive 2. And now out here we have 6 minus 4, which is going to be plus 2. And that's it. We can see that this looks just like vertex form, which is y equals a x minus h squared plus k. And you can notice how this is in the same form as this one. So we have put this in vertex form. Alright, I'm going to skip down to number 3 because it's very similar to number 1. It doesn't have a number out front. Okay, so for number 3, the first thing we'll have to do, sorry, it's not supposed to be 2 plus signs, is put x squared plus 2x. I'm going to put a plus blank. And on the outside of the parentheses, I don't have to change the sign, so I'll just put plus 7 and a blank. Alright, and what goes here, this is going to be b over 2 squared. So 2 divided by 2 squared, so that's going to be 1 squared, which is 1. So on this side, so I won't alter the equation, I'm going to have to change the sign and make it minus 1. Alright, from here I just changed this perfect square trinomial to a binomial squared. So it's going to be x, always x, and then the number right here is going to be this, your b, divided by 2, which was a positive 1. And now on the outside I have 7 minus 1, that's going to be a positive 6. That's it. Okay, so now let's look at numbers 2 and 4. The only difference between 1 and 3 is that, of course, this one has a 2 out front. Okay. So in completing the square, first we'd have to bring out 2 or divide by 2. Well, in vertex form, we're going to keep our a on the outside of the perfect square binomial. So in this case, our a was 1. So even though we didn't put a 1 on the outside, we know it's there. So for this one, we're going to have to bring our a out, which is going to be 2. Okay? When you bring the 2 out, you're bringing the 2 out of these first 2 terms, because we know the 17 is going to go on the outside of the parentheses. So to fill in what's missing in our parentheses, because again, we don't want to alter this equation, we're going to do 2x squared divided by 2. That's going to be x squared. And negative 12x divided by 2 is negative 6x. I'm going to put plus blank. Oops. Okay. Okay, so we put a plus blank, just like before. Plus 17 is going to go on the outside. Okay, and then I'll put a blank here. So let's go ahead and find b over 2 squared. That's going to be negative 6 over 2 squared, which is negative 3 squared, which is positive 9. So out here has to be minus 9. Okay, whenever your a is not 1, like in this case it's 2, you're going to have to multiply whatever this blank is by this number. And I'll show you why. Okay, so again, we're trying to make this be the same as our original. We don't want to alter it. That's why we need this 2, and I'll show you why. If I were to multiply this out and combine like terms, let's see if it adds up to be the same original problem. So in this one, I'd have to distribute 2 to all 3 of these terms. So that'd be 2x squared minus 12x plus 18. And then on the outside, I had 17. And then negative 9 times 2 is negative 18. So plus 17, I'm just taking away the parentheses, minus 18. So again, the reason I got these 3 is from distributing the 2 back out. I put a plus 17 here, minus 18 here. So if I combine like terms, notice how these are my like terms, and the 18s will cancel out. So we're left with 2x squared minus 12x plus 17, which was our original equation. So anytime you have an a on the outside, you're going to need to bring it over here to balance out this equation so it reverts back to our original. Okay, so now just change this part, this trinomial, to a perfect square binomial, leaving the 2 on the outside. So this will be x. Our b in this one is negative 6. Negative 6 divided by 2 was negative 3, so minus 3 squared. Now on the outside here we have 17 minus 18, and 17 minus 18 is negative 1. And that's it. Okay. So moving on to the last one, what is our a? Correct, it's going to be negative 4, so let's bring that out. What is negative 4x squared divided by negative 4? That's going to be x squared. Negative 24x divided by negative 4, positive 6x. I'm going to put a plus blank. On the outside will be negative 15, and I'm going to put a blank. What goes in here? That's going to be b, which is 6, divided by 2, which is 3 squared, which is 9. So over here should be minus 9, and then don't forget the times negative 4. So now let's just clean it up. We'll have negative 4 x, and then 6 divided by 2, that's going to be a plus 3 squared. Right here we have negative 15. 2 negatives make a positive 36. So 36 minus 15 is going to be a positive 21. Alright. I want you to try on the back, on your study guide, I want you to try 15 and 16 on your own with your partner. Alright, moving on. So we know how to put equations in vertex form now. On these, we're actually going to be given equations already in vertex form. We don't have to change it. And we're going to graph it using transformations. So transformations is something we've already done in this class, but just to review, the inside represents what you'll move on your x-axis. And let me write what vertex form is at the top. Ax minus h squared plus k. Right. Good. Okay, so here's vertex form. Again, what's on the inside right here is going to be moving horizontally or on your x-axis. So h equals horizontal. I want you to write that down. Alright, if h is less than 0, meaning that this is a minus h, so negative h. If h is less than 0, then you're going to be moving on the right, to the right on your x-axis. If h is greater than 0, so if it's plus h, you're going to be moving to the left. Alright, the k represents you moving on your y-axis. Okay, so you're going to be moving up or down. So k, I want you to put vertical. And if k is greater than 0, so if this is plus k on the outside, you're going to be moving up. K is less than 0, meaning that this is a minus k right here, you'll be moving down. Your a over here changes your slope. So this can either be a dilation, or if a is negative, it's going to be reflection. Go ahead and put a negative beside it so you'll know. So if a is, it's the absolute value of a, is greater than 1, meaning that this number is 2 or negative 2 or 3 or negative 3, remember the absolute value of a is greater than 1, then it's going to be a vertical stretch. If a is a fraction, so I'll just put a equals fraction, it'll be a vertical compress. Alright, and we know that this is a quadratic function because of the squared. And what type of functions are quadratic functions? What kind of shape do they have? It's going to be a parabola. And where's the center at, or the vertex? It's going to be at 0, 0. So this is what the parent function looks like. Now we're going to graph this one using what we know about transformations. So the negative 5, that's going to be moving on your x-axis horizontal, and negative 5 is less than 0, so this is going to move your graph 5 to the right. This one's going to be moving on your y-axis, it's vertical because it's plus 3. Okay, it's greater than 0, it's going to be moving up 3. And where from? We know that the parent graph starts at where? 0, 0. So that's where we're going to move from. So we go to 0, 0. We move 5 right. So 1, 2, 3, 4, 5. And up 3. 1, 2, 3. And then the slope, or a, if it's not there, we know is 1, right? So from here, you'll just go up 1 over 1. And then make it symmetrical. Up 1, back 1. And go ahead and draw your parabola. Okay. Alright, so for the next one, we have two things going on. This negative out front, which is in our A spot, is either going to be dilation or reflection. Well, the reflection, or the negative, means, if you recall, that the graph, the parent graph, is going to be flipped upside down if there's a negative out front. That's called a reflection across the x-axis. So the negative is going to reflect it, or flip it upside down. And then the 3 on the inside is going to move on the x-axis. Because h is greater than 0, it's going to move it 3 to the left. So we start from 0. We go 3 left, 1, 2, 3. Draw our dot. And now our slope is negative 1 over 1 because of the negative out front. So we go down 1 over 1, make it symmetrical, and draw your parabola. Okay. I want you to try 7 and 8 on the back on your own. Okay, and we're going to do 9 through 12 tomorrow in class. All right.